So I will start a discussion here. Okay, I'll start a discussion, and what I can say is we'll take a topic for discussion. So let me see what can be taken here. Okay. Let me see what can be taken here. What discussion point of view? We can take anything. Right now the focus will be on the things, but not basically on the previous papers, because right now we are following a particular strategy to complete a syllabus step by step. So we can take few questions here if you want. Okay. I can take one question here first. Let me see the question. So let's try a question. It is a concept application exercise 1.1 from logarithm and properties. Okay. So I'll just so the question for which we are just discussing solve half is there to the power whole x to the power of 6 minus x to the power of 4 less than 2x square. So we need to solve this question. Let us understand how can we do this. We have half. We have half. Half is half to the power something. So if the bases are same, then also we have to think. So half to the power, and how can you bring half here? We don't know. Firstly, let's think if the ideas are coming up or not here. We have half. The maximum what I can do is the thing is we don't have that. What next I can do is I can write maximum like this, that is x to the power 4 x square minus 2 I can write, and 2 to the power x square. So we have to think here. Firstly, we have to think whether ideas are generating here or not. So right now, we're trying to solve a question where I feel are the ideas being generated or not. That is the first thing. Okay. So what I can say, base is not same. If the base is not same, how can we equate it? That is the confusion. We don't have any pre-thought here. We have done few questions, but here still the confusion is how to start. And it is a JEE advanced level question, so we have to think how to start, and we should give a fair try. Seeing the solution or a hint, it is not suggested. We're just trying to understand how to start. We see here in this question, I can say that basis is same, we can solve it. If the bases are same, we can do something. So 2 to the power x square. How to start the question? That is a confusion here, right? How to start the question? There is a confusion here. So base same, how can I make that is a... So what thing I can do is I can keep the base same by converting this to 2 to the power minus 1 whole x to the power 4 x square minus 2 is less than 2 to the power of x square. I can do this, and if I multiply minus 1 there, so initially what was there? So 2 to the power minus 1 will be in the multiplication here, okay? So minus 1, and this is x to the power of 6 minus 2 to the power of x to the power of 4, 2 to the power of x square. We have to understand how to proceed, okay? Base same is one of the conditions. So what I'm trying to do is, right now the base same condition I'm trying to do, because such condition we have done it earlier also, right? It is a minus x to the power of 6 plus 2 to the power x to the power of 4 less than. So here what I can say is प्लेसमेंट का डेटा देखना पड़ता है. So here I think something is required here, right? So we have 2 to the power of 2x to the power of 4 minus x to the power of 6 is less than 2 to the power of x to the power of 2. So base is same. On LHS we have some power, RHS somehow it is lower value. It means that it basically means that value is lower, so x square is greater than, so I can say here directly 2 to the x to the power 4 minus x to the power 6 is less than. If it is less than x to the power of 4, if it is less, then only it is possible, I guess. What I can say, so if x square is bigger, okay, if x square is bigger, then only it feels like, so obviously I can say that if it is bigger, then only the If the exponent in the RHS will be bigger, then only because the base is same, right? So here, what common I can take is x to the power 4 I can take common. Is it possible to somehow do one thing that it is 4 I will write here, x to the power of square. So should we go like this or no? I think we should bring it together. That be correct to bring it together. So 2x to the power of 4 minus x cube and is minus x square less than 0. Obviously subtracting both sides by x square. Further, this can be written as multiplication we can do, and so x square if you take outside it will be 2x square. So if I do minus 1 multiplication, that will lead to x cube plus x square minus 2x power of 4 greater than 0, or x square if I'm taking outside it will be x to the power of 4 plus 1 minus 2x to the power of square, it is greater than 0. See, multiplication of two algebraic identities is resulting a positive value. It means that this is positive and negative positive, or you can say, so here it implies that x square is greater than 0. Obviously, or x to the power of 4 minus 2x square plus 1 is greater than 0, and x square is greater than 0, so x is greater than 0, or here it is a biquadratic form I have got. So we can solve it. Let y is equal to x square. So this will be y square minus 2y plus 1 is greater than 0. And further, this will lead to y is equal to, equating it to understand for the factorization, I am just equating it now. So minus b, that is 2 plus minus under root b square minus 4ac upon 2a. So this will lead to 2 plus minus, this is 4 minus 4 upon 2, or this is 2 by 2, or 1 is coming up here. It implies that y is equal to 1 or x square is equal to 1, implies that x is equal to plus minus 1. This is greater than 0 and plus minus 1. I think we are in the right direction. Something is required, and then we can solve the question. So x is greater than 0 and x is equal to plus minus 1. Okay, x is greater than 0 and x is equal to plus minus 1. Okay, so x is equal to plus minus 1. After solving this, or in this format, I can say x is greater than 0 or x minus 1, x plus 1 greater than 0. This we can say. Okay, so if you just on the number line, if you just write, because the critical points are 1 and minus 1, so we can try. So this will be leading to minus 1 and plus 1. Okay, and if you put any value 2, let us say we put, so it will be positive here, and 0.5 you put, it will be negative, and less than, if you put, for this inequality we are just working, so less than, if you put this minus 2, this will be again positive. So that x belongs to greater than 0 it is, and this is also there. So union of these two will be there, right? So the union of these two will be there. So it means that it is greater than 0 we are working on, so, and not a negative value, we don't require them. It should be greater than 0, and also greater than 1 basically. So I can say that this part is justified for this one. Okay, right? So this greater than 0 means 0 to infinity, open brackets, union. So we have minus infinity to minus 1, union one to infinity. Okay, so if you combine all of them, so I think, let me just check it. I think I'm going the right direction. Just to combine them, you have to think. Working looks to be right. We're just checking it, right? So x is not equal to 0. So here only one thing, so there x is not equal to 0, -1 and 1. Or this can be further written as x belongs to all real numbers minus 0 plus -1. So this is can be the answer. Okay. So r minus 0 and plus -1, that's fine. It will not be 0 and plus -1. So it is done, but I will just some other way we will try this. Okay, looks like it is done. So yeah, that's fine. I'll just put up a rework here. Okay. What are logarithmic functions? Let us understand, and we'll come back to this type of paths again, right? So logarithmic function, the logarithm of a number to a given base is the exponent to which the base must be raised in order to produce that number. For example, logarithm of 1000 to base 10 is 3, because 10 to the power of 3 is 1000, that is 10 to the power 3 is equal to 1000. We write 10 log 1000 to the base 10 is equal to 3. Here 10 is called the base of the logarithm. Similarly, log 64 to the base 2 is the value to which 2 must be raised to get 64. Since 2 to the power of 6 is equal to 64, log 64 to the base 2 is equal to 6. Thus, if a to the power of x is equal to y, then we have log y to the base a is equal to x. If in exponential function y is equal to a to the power of x, x can take a real value, so that log y to the base a can also take any real value. Also, y is equal to a to the power of x is greater than 0. So log y to the base a is defined only if y is greater than 0. It is obvious that it should be defined only if y is greater than 0. Yeah, thus we can define logarithm function as fx is equal to log x to the base a. A should be greater than 0. Okay. A is not equal to 1, having domain 0 to infinity and range r. Logarithmic function is actually inverse of exponential function, so domain and range of exponential functions are range and domain of logarithmic function. So that is good. Okay. So we'll wind up the session here.